Hi, welcome to this revision lesson on conservation and dissipation of energy. We're going to start this session by looking at the principle of conservation of energy, and that's the most important rule in physics. And it tells us that energy cannot be created or destroyed. It can only be transferred from one type to another or stored within a single type. If a system is closed, then no energy can be transferred in or out of the system. And we remember from last time that a system is an object or a group of objects. Okay, so if it's a closed system, energy can't be transferred in or out of the system. An open system, energy could be transferred in or out of the system. What this means is that in a closed system, the amount of energy you start with in that system must be equal to the amount that you end with, because you can't create it, you can't destroy it, and because it's a closed system, you can't add any more into the system or take any out of it. So sometimes we do get what we call wasted energy, and that's what happens when energy transfers take place and not all of the energy is transferred into a useful form. Some of that wasted energy, or some of the energy is wasted and dissipated or spread out into heat in the surroundings. So the energy is still there, but it's no longer in a useful form, and so we say it's wasted. Now you need to be able to explain how we can reduce some of that waste energy, and here are some ideas. So if we've got loose parts that might be rattling, then we could tighten those loose parts. If there's friction between different moving parts, then we could use lubricant on the surfaces to reduce the amount of friction. Electrical heating in wires could be reduced by using low resistance wires, and heat loss through conduction can be reduced by surrounding it with an insulator. That brings us on nicely to thermal conductivity, and thermal conductivity is the ability of a material to transfer thermal energy. So the higher the conductivity, the more heat is being transferred per second. And the best insulators have the lowest thermal conductivity because they're transferring the least amount of heat per second. So if we have a building, we would have a building would cool faster if the walls are thin and have a high thermal conductivity. Whereas if we wanted our building to stay nice and warm in winter, we would want thick walls that have a low thermal conductivity. Okay, the last thing you need to know is the equations for efficiency. So two different equations, very similar. Efficiency equals useful energy output divided by total energy input, or efficiency is useful power output divided by total power input. And if either of those you want to get it as in the form of a percentage rather than a decimal, you then need to times by 100%. Remember that you need to have energy on both the numerator and the denominator, or power on both the numerator and the denominator for this equation to work. Okay, hope you found this helpful. I'll see you next time.